Okay, good morning, everybody. My name's Arnu. I work as a BA on the SARS project. I studied informatics at the University of Pretoria. So I thought today I'd talk to you all a bit about digital twins. It's a buzzword that's been around for a while, and you may have heard of it before, but you're not entirely sure whether or not it's new, relevant, or important. But this technology is impacting the way we interact with the digital world and how we, through that, manage the physical one. But before we look at its future, I would like to visit a story from the past on digital twins. So in April of 1970, the Apollo 13 mission faced a critical situation. So 2 days into their mission, an oxygen tank exploded on the spacecraft, putting all the astronauts' lives at risk. And although they weren't able to reach the moon, they were saved due to what many consider to be the first practical application of a digital twin. So NASA had simulators of the Apollo 13 spacecraft in Houston, right? And these simulators were kept up to date with real-time data streaming in from the spacecraft in space. It's damaged spacecraft to try and keep the simulators up to date with the changing conditions of whatever is happening up there. And through this, they were able to sort of develop strategies and predictions on how they could guide these astronauts on board this spacecraft on what they need to do to try and come home safely. Now, this story brings out several important points. First, we saw that there were models and right? So the models would have been the simulators they had on the ground in Houston. And these models would have been an accurate representation of the spacecraft as is, right? And then there were data that they were getting in from this, from the damaged spacecraft in there, constantly streaming this data, and also from astronauts' observations. Any observations they may have made on board, they accounted for as well. And then there was a process of data assimilation, right? So they took all of that data coming in from that spacecraft, that real-time data, and they combined this with their simulators, right? The model, to try and then change the simulators to reflect the state of the damaged spacecraft. And then based on this, right, that brings us to the last important point, is they were able to make predictions, right? They were able to understand potential future states of the spacecraft and try and sort of develop strategies on what these astronauts could do to come home safely, right? So they were able to test these things in a virtual environment before applying it into the actual spacecraft, right? Now, you might still be wondering what exactly is a digital twin then? And if you ask several different experts to define it, you'll get many different answers. So instead of going there, I'm going to try and keep this simple and high level and just sort of work out what the different components of a digital twin is. So if you, for example, wanted to make your own one, this is what you would need to consider. So firstly is that we have some sort of real system, right? So this is the real object that we want to model, right? And this could be a bridge, a human, an organization, a car, anything. And then in this digital twin setup, we would create a digital representation of this real object, right? And this is a digital artifact, right? It's not real, it's virtual. It lives in a computer somewhere. And depending on what we're modeling or how big this digital twin is, it could be something simple. It lives just on a desktop computer, or it could require significant deployment, some sort of cloud deployment. And it's not necessarily like a 3D model or something. Mostly when you look at digital twins, this is what you would see, but it could just be a sort of dashboard or something that reflects that real system. But importantly is that this digital twin is connected to this real system in two ways. Like firstly, we have sensors all over this real system that is busy bringing in data into our virtual version so that we can ensure that it is always in line with this real thing that we are busy monitoring. And another essential feature is its ability to affect this real system. So with our digital twin, we would like to make changes to this real system, right? And we would do this through effectors. And effectors could be anything, right? If I have a car engine, for example, car engines have an ICU, so a control unit that you could use to make adjustments to the real system through the digital twin. So that would be the effector in that case. But it could be more complicated. You could create a virtual representation of an entire organization, like a medical facility, for example, with various workflows and processes that are happening there. And then your effector might be an actual human that would need to go and make changes based on whatever insights the digital twin gives you. Now, the primary reason we built a digital twin is that we would like to provide additional services, right? So you build a digital twin for a very specific use case. You don't build it just to build it and just collect, you know, millions of lines of data without reason. You need a specific use case to build it. So for example, if I want to maintain a bridge effectively, I could build a digital twin of this bridge, a virtual version of it that that I could bring enough information in to create a digital version, a model of this. It would allow me to perform analysis, make plans, provide decision support, or even have the digital twin make decisions to go and apply it through, say, a human decision maker to go and apply those changes. And this is where the value of digital twins really come from. Now, let's dive a bit deeper and look at what's really happening inside of the digital twin. So we said that there are sensors which are collecting data from our real system, and that then we have effectors. So eventually we would like our digital twin to make changes to that real system. Now between the sensor and the effector, there are various steps. So firstly, we are going to be collecting a lot of data from the sensor. But at this point, this data is just numbers. It doesn't mean anything yet. We need to prepare this data. We need to process it and bring meaning to it before it means anything to us, because this data could be coming from various different sources, and sensors are also fallible, right? They might not always bring me data, or it might be inaccurate. So we need to prepare this data properly so before it becomes usable. And then that brings us to the analysis step, which is going to help us understand what this data exactly means. And this is where we're going to be turning data into information and knowledge so that we can actually make decisions on this. So this involves combining data from various sensors and even utilizing knowledge, or like a built-in knowledge from a knowledge model. So if we model a digital twin of an aircraft engine, for example, we might already have a model of that aircraft engine that serves as a sort of basis for how an aircraft engine should act. And then based on data we collect from the sensor, we then can sort of compare it and say that something might be wrong. And based on this analysis step, we then produce that up-to-date model of the real system, which we can then present to users as is. We could use it for what-if analysis. So what if I make this change? What could potentially happen? And this all forms part of the overall planning process. So if this analysis through this planning process identifies any issues, we could eventually make decisions, right? So that leads us to, sorry, it's gone stuck black. That leads us to decision making. Right, and this decision making could be something automated, such as the example of the engine, or it could be something that involves human decision makers, right? But important thing is the digital twin can involve various things. There's AI, modeling, planning, decision making, all just to create a comprehensive version of the real system. Now let's look at a real example of a digital twin. So in Norway, they are busy creating digital twins of all of their bridges, right? So virtual versions that they are trying to use to predict the future, essentially. And this is a real story. So they have about 5,800 bridges in Norway, and these bridges are aging and they require regular inspections. But these traditional inspections still only happen about every 5 years, and they often miss critical issues, such as how bridges behave under different loads or its overall integrity. So to solve this problem, they installed IoT sensors all over this bridge, which is continuously monitoring the condition of this bridge, collecting data and uploading it to their virtual version of this bridge, right, in some cloud-based system that they have. And they set it up so that if there's any critical situation that comes up, this sensor will trigger and send out an alert. And that's exactly what happened in April of 2021. So such an alert was triggered by one of these bridges. And thanks to real-time monitoring, they were able to immediately divert traffic from this bridge and start working on a solution, right? And these sensors detected critical changes in this bridge on how its condition and how it was behaving that traditional inspections would have missed. And the benefit of digital technology in this case is that it not only increased safety, but it also helped reduce costs, because emergency repairs are far more expensive than just being proactive and predictive and planning your maintenance, which is what digital twins excel at. And if you look at some other examples of this, Singapore at the moment is building an entire virtual version of their city, right? So they have thousands of sensors all over their city that is continuously monitoring, collecting data on their buildings, their transportation networks, utilities such as light, water, power, whatever it is, all to try and optimize traffic flow, manage their energy distribution. They could even assist emergency services with real-time updates, right? And all of this like improves their own planning, their sustainability, and even their residents' quality of life. Another frequent use of digital twins that you'll see would be in manufacturing, right? So in manufacturing, they would create an entire digital replica of their factory floor, right? And each machine and component would be replicated and mirror it in this digital environment, and they're constantly going to collect data from this and monitoring it. And this can help them predict equipment failures before they happen. They could schedule maintenance during optimal times to minimize downtime. And very importantly, it also helps them with virtual testing. So in their virtual environment, they'd be able to go and move robots around and see how this possibly could affect their real system in the virtual environment before they make any changes. A great example of this is BMW, who are using NVIDIA Omniverse, which is a real-time 3D graphics collaboration platform. And they created a virtual model of all their factory floors, which they are busy using to optimize their production processes for a new electric vehicle plant that they plan to implement. Now, looking ahead, digital twins is promising and expansive. And as technology advances, digital twins will become more sophisticated and integrated across various sectors. So in healthcare, for example, you could have digital twins of individuals, right? And you can simulate different responses, see how to respond to treatments, and even predict health issues to provide highly personalized care, right? A smartwatch, in a way, is an example of a simple digital twin. Similarly, in agriculture, digital twins of farm could monitor soil health and crop yields, to optimize those crop yields. And as fields such as AI and machine learning are advancing, digital twins of manufacturing plants could become even more sophisticated, where digital twin could maybe possibly run the entire factory itself and make those changes based on all the data that it's getting in. Now, as examples show, this ongoing development of digital twins promises to unlock new opportunities for innovation, efficiency, and resilience across industries that could shape a smarter and more connected future. Thank you.